thanks for listening to my first introduction video. If you haven't watched it, please go back and take a look at it unless you know how OpenRocket works. But right now I'm going to take you through building a very simple rocket. We're going to look at a one-stage rocket. So first thing we're going to do, go over to your file. We're going to do new. We're just going to click new. It opens up a new window. I'm going to go ahead and erase this second window. I don't need to save it. And so this pops up. Nothing pops up. Well, like nothing pops up basically. You just have this rocket with sustainer. And you can see that you can't really choose anything over here right now. The only things you can choose is a nose cone, body tube, and transition. What I typically start with is I build my rocket from the top down. And so I'm going to choose a nose cone basically. So I choose this nose cone and it automatically has some presets. So nose cone shape, you can choose a bunch of different ones, conical if you want, ogive, ellipsoid, power series, parabolic series, and hack series. I typically choose the hack series. This is kind of like a von Karman one. You can choose the shape parameter if I want to change it, go up and down. You can see it barely changes stuff, but I'm going to change it to 0, or keep it at 0. And I'm going to change the nose cone length. I'm going to make it just a nice round number. I'm going to go up to 8 inches. So you can see it updates it in real time, so you don't have to do anything else. Oops. Okay. So base diameter, right now, like I said, one of the difficulties in working with this is a lot of the rocket components you're going to buy are like, 38 millimeters, 29 millimeters for rocket motors. And but a lot of the competitions we compete in, they want all the units in imperial numbers. So I have it preset to imperial units, but I often usually have to change it to metric units. So what I'm going to do for the base diameter, we're going to make a minimum diameter 38 millimeter motor rocket today. And when you buy a typical fiberglass motor or like a fiberglass tube, they're usually about 42 millimeters. So I'm going to change that base diameter to 42 millimeters. The wall thickness, that depends. It's about 2 millimeters, which is pretty good. And you can choose if you want your nose cone to be filled or not. All depends on your mass. You can see if we fill it, the component mass down here, right now it's at 0.779 ounces. If I choose filled, it goes all the way up to 3.38. So that's something you can choose to do. Your component material, right now it's set as cardboard. Typical materials are like fiberglass, phenolic, maybe PVC. I'm going to change it to fiberglass. So say we bought like a kit from Mad Cow Rocketry. We're going to change it to fiberglass, like say what's one of their guys. So we change that, and you can see your component mass actually changed. Component finish, this one is something we have troubles with. We don't really know which one, how these finishes relate to real life numbers basically. We don't know the correlation between that, so we don't know if they're rough paint. In here actually simulates to a very smooth rocket in real life. That's something we still have to test. But for now, just keep it at regular paint. And so that's your first kind of this general section right here. The other thing you're going to want to change is your shoulder. So the shoulder is that little section that kind of pops out of the nose cone here, if you're going to have one. So nose cone shoulder, typically if you have a 42 millimeter fiberglass tube, your inner diameter should be 38 millimeters because it has to fit that 38 millimeter motor. And typically the length, you want to go typically at like a body, like a diameter inside of the rocket. So we're going to choose 38 millimeters. You can see it pops up down there. You can change your thickness. Let's change it to 2 millimeters, I guess. So it's changed to 2 millimeters. Doesn't really show up on here, but that's okay. An end cap, you can choose to cap the end or not. I typically keep it open, but it's up to you guys. So you can see we made our nose cone now. The next thing we want to do is we're going to go ahead and add a body tube. So what you're going to do is you're going to click on this guy, or you don't have to click on it if you don't want to, but it's going to pop up anyway. But then we're going to add body tube. So you go up here, you select body tube. And that's going to automatically pop up below your nose cone. And so you can see it has these presets in here. The outer diameter, let's check what that is, 42. So that's nice. If you click this automatic, it'll automatically do that. If I don't click it, you can see that the body tube increased in size and it's 50 millimeters. But I usually click on automatic, so you can change the nose cone diameter and it'll change the body tube diameter as well. Body tube length, set there. Inner diameter, let's check what that is. Sometimes it changes. No, it's 38 millimeters, which is good. Wall thickness, it automatically calculates. It's at 2 millimeters. And we can choose to fill the whole thing, but we're not going to do that because usually they're hollow. Change the component material. We're going to go ahead and change to fiberglass. And we're going to change the body tube length. Let's change it to about, say 30, something like that. So 30 inches right now. And I know working with imperial and metric at the same time is kind of tricky, but we do what we have to do. So because this is a minimum diameter rocket, I'm going to show you something that's really helpful. So you can say this component is a motor mount. If I click this as a motor mount, it'll automatically be able to show up in your configurations. And so you can put motors in it. You can also choose the motor overhang, which I'll show you later what that does, because typically your motors are going to stick out a little bit. And you can also choose the ignition. So that's kind of an interesting thing you can do. But right now, the fiberglass tube is in there now. Okay. So now that we have this tube, it's interesting to look. If I click on the nose cone, a couple other stuff pops up on here. You can see that you have the inner tube, coupler, centering rings, stuff like that. What I'm going to do now is click on the body tube, and you can see more stuff pops up, especially the fins, because that's where you're going to be able to add the fins. I'm going to go ahead and add a trapezoid fin set. So this fin set shows up. You can see over here in the bottom. Let me change the fit a little bit. I'm going to increase it actually. I'm going to slide on down to it. So this pops up. You have a couple options here. You can convert to freeform. If I convert to freeform, basically I can look at the shape and I can change the shape at will on here. I typically don't like doing that first, so I'm going to go ahead and Control Z. Yeah, I have to exit out of here. Control Z. So I Control Z. Oh shoot, I just broke the whole thing. Right. But anyway, okay, so I'm going to delete that real quick. Alright, so I can't delete it there, but say we didn't want to do that, I can delete the fins right there. And I'm going to go ahead and add a new set of fins. So that the convert to freeform is something that can only be done once. You can't go back, which is kind of a bummer. But what I usually start from is this section right here. You can see you can choose number of fins. We're going to go ahead and choose 4. And you can see it changed it down here. We have 4 fins now. I'm going to select the thickness. We're going to go make sure it's in inches, and we're going to do 1/16. Okay, so it pops up. Fin cross section, typically you're going to try to bevel your fins. If you do that, I recommend saying they're rounded, and you'll see what that does to your apogee later when you mess around with that. Component material for the fins, change to fiberglass. Finish, we're going to keep it like that, and you can add a fillet basically to your rocket, and all depends on you. I typically say we have about a 1/4 inch fillet, and that's going to show up. And the material there is a little bit tricky. I usually try to find the rocket epoxy that they have on here. We typically do like a glass or a phenolic. We mix phenolic with epoxy and put it on there because it's really lightweight and pretty strong. So I'm actually going to choose, I'm going to do craft phenolic for now, just for the sake of the video. And all right, so now we're going to go back to here. So you saw we changed the number of fins. Fin rotation is something I typically don't change with. Fin cant, we can mess around with that, and you can see that our fins are actually changing their cant. This is going to cause you to spin, so I typically keep that at 0 because I don't want it to spin around. The root cord, you can increase that, which is something we typically do. You increase the root cord. Tip cord, if you want to increase that as well, you can see what that does over here. So the root cord is on this side, the tip cord is on the top. So I'm going to change the tip cord back to something that I probably would use. Okay. We're going to change that to exactly 1 inch, just to make it a little simpler. And we're going to change that to 4 inches. Okay. And the height, this is something that you can mess around with. We're going to change it to 2 right now. And you can see it looks a little odd, but we're going to change the sweep length. So if you can see, when I change the sweep length, if I change it like that, it also changes the sweep angle. So you can change both of them. You can change one of them and it'll affect the other one. But what I typically do is I mess around the sweep angle. And if we mess around that, you can see it's going to push our fins backwards a little bit more. And that's just a little bit useful to try to increase the stability. So this section right here, the positive relation to the rocket, basically you can change the fins to be up or down on the rocket. So if I change it down, you can see that our fins drop down a little bit. If I make it a negative number, it goes up on the rocket body, which is pretty useful because typically when your rocket's going to be hurtling down to the ground with the parachute attached, the parachute's attached up here, and this is going to be the heaviest component of your rocket, so that should impact the ground first. And if you keep your fins like say like this, it's going to hit fin first, which is usually pretty weak. So it might actually snap off one of your fins. So what we typically do is we try to shift the fins up on the body up to 1 inch, but usually for smaller rockets we choose about 1/2 inch. That's pretty typical. So everything's changed on here. These fins look pretty good. And another thing we typically do is we try to cant the fins forward, or not cant the fins forward. We try to shift the fins, the sweep angle in the back. We try to shift that forward instead of having it like basically vertical or coming back off the edge like this. Because again, those fins might impact first, but if you shift your fins forward or sweep them forward like this, it actually, they might not strike the ground first. It might hit this bottom portion of the rocket first before impacting one of these fins. So you don't really want to lose one of your fins because it's a big pain in the butt to try to deal with. So we have those fins attached there. Next thing we're going to do, we're going to add a parachute. I'm going to fit this real quick. We're going to add a parachute basically to our rocket. So you click on the body tube and you can choose parachute. And you can see when I clicked on parachute, it popped up over here. And it's in the body tube, and that's where we want it. So you can change the diameter of your parachute. Right now, I don't know why I changed it to millimeters. I'm going to change it to inches. So let's say pretty typical one is about 36 inches, we're going to say, for our rocket. You can change the coefficient of drag if your supplier knows what the coefficient of drag is. I know one supplier has stated it's about 1.85, but we're going to keep it at the 0.8 right now. You can change the number of shroud lines. 6 is pretty typical. You can also change the length of them. But if you make your own parachute, you can easily change these to the specifics of your parachute that you made. Position relative to the parent of the component. You can see right now it's at 0, so it's sticking here right at the top. I could change this to the bottom or the middle, and it's changed right now. It's like fixed right here, and it says it's 14 inches there. But if we change it to the bottom of the component, again, it says it's 29 inches. So I'm going to go ahead and change that back to the top of the component. And then I'm going to shift it down using this guy. So we're going to try to stick this parachute about right here. And then you can change the package length. We're going to make it pretty big. And our rocket's only... So let's change this to exactly the inside of the rocket, 38 millimeters. Okay. So this is something you can mess around with. You're really going to have to play around with how tight you can pack your parachute and still feel comfortable with it actually deploying. It's hard to estimate inside OpenRocket, but it's something you're just going to have to get and test in real life, because you don't want to underestimate the size of the area you're going to need for your parachute. If you underestimate the volume, you're going to be in a pickle, because you're not going to be able to pack your parachute down small enough to fit inside of it, which could mess your flight up. And this is something you can also choose as well. Deploys at first ejection chart of this stage. That's going to eject when your motor is going to inject something. But say you didn't want that and you want it to go off at apogee, which is typically what you want, you can choose apogee. You can choose a bunch of these other guys. These are going to be useful when you're doing dual deployment, which is what we're going to do as well. And then you could say at apogee plus a second or something like that. But it's up to you. So we added a parachute. Next thing we're going to add is a shock cord right here. We're going to add some shock cord. So we added some shock cord. You can see it showed up here. You can choose the length of your shock cord. And we had about, I don't know why I keep changing it to millimeters. But we're going to make it about 3 times the length of the body. And again, you can see like OpenRocket thinks, hey, you're able to fit, 90 inches of shock cord, which is well over 6 feet tall. I don't know, that's 90 divided by 12, whatever that is. Packed into this like 1 inch square, which isn't possible. So that's something you're going to have to figure out how to do on your own, is how tightly you can pack that shock cord. And you can change the material. We usually have, so they have a bunch of materials here. We're going to choose tubular nylon right here, this guy. Okay, and you can change the position of it. So we're going to go ahead and shift it down. We're going to change the length. We're going to say it's pretty big. Package diameter, let's change that to 38 millimeters, just so it takes up our entire tube. Okay, and then we're going to shift it back up so it sits right underneath the parachute there. Okay, and that's basically what you can do for here. You can override the mass. And then we're going to close that. So now we have the basic components of a rocket. What we're going to add now is what I showed you earlier in the first video, is motor configuration. So you can see here, we're going to hit new configuration, and it's going to be attached to the body tube. So we're going to change this. We're going to rename it to Rocket Test 1. Okay? And so we double click right here, and you can see our motor selections pop up. It's automatically limited based on your body tube size that you chose, because remember we chose to be a motor mount, and it automatically filters the motors. So right now it's at about 1.5 for the motor diameter. That means your only choices are going to be 38 millimeter motors, up to 38 millimeter motors. And we're going to go ahead and choose one that we've used in the previous competition. We're going to use an I-285 Redline from Aerotech. It's a I motor with 416 seconds of impulse. We're going to choose that guy. If you want to look at the details of it, this is what it is. But it's a pretty good I-size motor. You can see when we clicked on that, it populated a whole bunch of stuff down here in our view, basically. And if we go back to the rocket design, nothing's changed on here. But if we look over here, we can see the stability of our rocket, which is about 2.74 right now. So that's pretty stable. That's very stable. You can see the CP, CG location. You can see the length up here. You can the diameter, which is 42 millimeters. the mass of the rocket, so 36 ounces, and you can also see how high we're going to go. So we're going to go about 6,648 feet and hit about Mach 1.12 with a pretty high acceleration. And so what we can do with that now is, because a lot of these components we chose fiberglass for this. This is fiberglass as well, and so is this. So our rocket's, it's pretty light and it's going to go pretty high. What I always recommend doing, what we always do, is we take all the components of our rocket, and before we assemble everything, we find the exact masses in here. And what you can do is you can override the masses in here. You can override the mass. You look at, say, oh, it's 2.68 here. If that's too high or too low, you hit override mass, and we're going to change it to 3 ounces. Say that's what we actually found out what it was. And so you can change that. You can do that for each of these components, which is what I highly recommend doing, because it's going to give you a more accurate simulation. Okay, and so what I'm going to do now is, because our stability is so high, I'm going to try to lower it to 1.5, just to have some fun. And so typically what I do, I start out with, is I lower the height. So I'm going to lower the height to about 1.5. And you can see when I did that, it dropped down to 1.67. So that's pretty good. And so once you saw that we did that, it actually changed our apogee. So we're almost hitting 7,000 feet right now. And that's something you can do to get higher apogee, or even if you want to try to make the rocket go lower or hit a specific point, you can mess around with the height, you can mess around with the sweep length. It's all going to be up to you and how you want your rocket to look and basically perform. So if we want to change also, something that also affects the altitude, if I change this sweep length, you can see as I mess around with it, we've actually dropped our stability to 1.64. So we dropped about 0.02. Or I can't remember what it was before, but we've dropped some stability factor. But you can see when we did that, we actually increased our apogee, because the wings, or the fins are actually swept now, so it's going to cause less, or the sweeping of the fins actually increases your altitude a little bit. If I keep sweeping these back, you can see we keep increasing here, but our stability factor has gone down a lot. So I'm actually going to change those back to about right here. So we have that little bit of a forward sweep. They're not going to impact the ground first. I know I said I'm going to try to get to 1.5, but 1.68 is good enough for me. Okay, so this is your basic rocket right now. We've got a motor in there. You can add a bunch of different motors if you want. But we're going to head over to flight simulations. We're going to hit new simulation, rocket test 1. These are all the presets I have in there for our Spaceport America competition. I'm not going to change those right now, but if you want, let's change. Actually, I'll change one of them. I'll change this to feet. So 17 feet. That's a really long launch rail. Typically people won't have one. I'm going to change it to 7 feet. We're going to hit simulate and plot. Okay, it gives you the options, like you want to do, right now it's set on stability and time. I'm going to change it to vertical motion versus time. So when I change it to that, you can see this pops up. We're hitting almost 7,000 feet. And if we zoom in, we can see a bunch of stuff, you know, motor ignition, motor burnout, apogee and recovery system device deployment. So that's a lot of fun. We can see what's going on there. It's really good for submitting technical information if you guys need to figure out what you're doing, especially for competitions. It's really great to show that you know how high your rocket's going to go, and it's just not a complete guess. Let's also double check the stability. Let's see, stability plot. All right, you can see it's really stable, it looks like. So it starts off below 1. So one thing I'm going to do, I'm going to double check. I'm going to add launch rod clearance. So we want to make sure it's stable off the launch rod. And it should be, I believe. We'll find out. Ooh, just barely, it looks like. It looks like it hits 1 just off the launch rod. So what that means, if it's actually stable, unstable going off the launch rod, let's change those parameters. Let's go ahead and change the, no, we have to do a new simulation. So let's go ahead and change this instead of, see, it automatically defaults to 17 feet. So let's go ahead and change this to 4 feet, see what happens there. So this might not end up very well. Since we're not vertical or stable enough off the launch rail, it might spin around. Okay, well, it looks like it was fine, which is kind of a bummer. But typically, if you have your launch rail pretty short like that, it won't be stable off the launch rail, and it'll end up doing a bunch of corkscrews in the air and possibly hitting something, which is really bad. We're going to do stability versus time, see what happens, and we're going to add launch rod clearance. Okay, let's see. So yeah, you can see when I change the launch rod length, you can see it launched off there at about 0.85, which isn't very good. You really want to try to get it above 1 off the launch rail. But that's your typical rocket. That's your easy to build rocket. One thing I'm going to do real quick. Say we didn't want to have a 38mm motor in here. say we wanted to do a 29mm motor, which is pretty typical from one of these kits that you can buy. 38mm motor, as you can see, it gets about Mach 1.13, so that's going to go really fast and might not be totally recommended for your first rocket. So we're going to hit new configuration here, just to make it a little bit easier on us. So we have no motor mount in there, or no motor in there. And what I'm going to do now is I'm going to select the body tube up here. You can see it highlights it down here. And I'm going to add a inner tube, this little inner tube. So it pops up on the inside. You can see this little red component over here. And what I'm going to do is the outer diameter I'm not going to worry so much about. But I'm going to say it's about, let's see, typical 29mm motor, I'm going to say it's about 32mm, something like that. Okay. Inner diameter, we're going to change that. It's 18 right now. I'm going to change it to 29 because that's what we want to stick inside there. And you can see it's added a little thin wall in there, so that's good to know. So that means we've done something right. We're going to change the length of it. We're going to change it to 10 inches. See what happens. Okay, so it's 10 inches now. And position relative component. Okay, cardboard material. We're not going to, well, we're going to sit with craft phenolic. Say we got, or no, we're going to do fiberglass because that's going to be, that'll probably be in a fiberglass kit as a fiberglass motor mount. And then we're going to say this component is a motor mount. So that's something we can do. And we're gonna close that. But OpenRocket, like I could launch this right now, and OpenRocket would be, I think, okay with it. But typically, you're gonna want to, have some way to glue this tube inside of your rocket. So we're gonna add centering rings. And when I add a centering ring, we're gonna say it's plywood. Well, we'll just say it's fiberglass because it's easiest right now. Diameter, it's preset all these because it's set on automatic. And you can see inner diameter is 32 because that's the outer diameter of our motor mount. Outer diameter is 38 because that's the diameter of our inner diameter of our rocket body, and we can change the thickness as well. These are at 2mm. Again, difficulties of working with imperial land metric at the same time. We're going to change that to 1/4 inch. That's typically what we use. If you're doing one of these smaller rockets, maybe you want to do 1/8 of an inch. 0.125. And so you can see I can mess around with the height of this, and I can move it up and down, or the position of it, and you can see it shifts up and down. Now, you can keep doing this. You can keep adding centering ring and move it up and down and change all the components. But if you wanted to be a little bit quicker about it, you go over here into your design tree and you hit centering ring. If I do Control C for copy, just on your laptop, I can do Control V, Control V, Control V, Control V. And it duplicates your centering ring however many times you hit Control V. I'm going to delete this guy. Okay, and you can double click on one of these guys and you can say, all right, I'm going to move you up. Or actually, I'm going to move it down. Okay, so I moved it down, and then I'm going to hit this guy, move it down as well. Just down a little bit farther. These are going to be arbitrary locations, but see, that's a much faster way than going over and clicking and having to change all the parameters. You can just duplicate them. Because usually when you're going to go to the laser cutter, or you're going to make these fins, you're going to make them all the same anyway, for the most part. Okay, and so we're going to go over here, and we're going to select a new motor. We're going to change this from that. So we're motor mounts now. We're just saying inner tube. And I'm going to select this motor. I'm going to choose an H220 because that's what we've used in the past. And I just know the name. H220. This is a pretty good motor as well. And you can see if you select that, boom, it pops up in your rocket. And so that's a lot of fun. So you can mess around with stuff like that. You can add larger motors, smaller motors, whatever you want. And we're going to double check our stability. You can see our stability is just fine, 2.56. And you can see our apogee's gone down because it's not as powerful of a motor. And what I'm going to do now is show you what I was talking about earlier with making your motor overhang a little bit on the outside. So motor overhang right now it's at 0, so it's sitting flush with your motor mount. But typically it's not going to be that. Typically you have a little lip on your motor and it's going to make it stick out maybe 1/4 inch or something like that. So you can see it sticks out a little bit, which is pretty typical, especially if you're going to have a motor retainer on there. We're going to hit close. Everything looks good there. Okay, so that's your basic rocket now that has a 29mm motor. I'm going to show you some more advanced tools now or options with the fins. So you had your basic fins. This is like body or body mounted fins, not through wall fins, which are usually pretty useful. We're going to go over here to fin tabs, and this is where you can actually choose the tabs that are going to go inside of your rocket body. It's automatically set these to match down with your exact inner motor mount, basically. Or that's your tab length, so it hasn't messed around with that a little bit. But we're going to go ahead and choose like, I don't remember how long it was. Let's say 2 inches or something like that. Height, let's start off at 1/2 inch. See how that looks. So you can see I did 1/2 inch, and you can see these little tiny squares. That's a little bit too big, so we're going to do 1/4 inch. that looks like it's sitting pretty well just for this demonstration. And you can also change the position. Like I can change if our tabs apparently want to be all the way up here, we can do that. But typically, you know, you want to you can choose the location. I'm going to choose it to be exactly in the middle because that's what we choose. You can choose the relativity of it. Okay, and we're going to hit close. So now you have fin tabs if you look at that. So you can see when I highlight it, you can see you have your fin, and they got these little tabs that sit down here. Okay, so that's one of the tools on there. And let's say you have your rocket. This is a typical one. It's basically a dummy rocket. There's no electronics or avionics inside of it. But say we wanted to add those, and they don't have a button up here that says avionics. It's just going to be a mass component, this portion right here. So component name. Say we wanted to add an APRA altimeter from, I think it's Perfect Flight. APRA. So an APRA mass type. This is where you can select if it's an altimeter, flight computer, deployment charge, stuff like that. We're going to say it's an altimeter. And what that does down here, you can see, is to add a little symbol inside of your mass component. So you can tell relatively what it is, and it makes it look a little cooler on this thing. The mass, if I remember right, I think it's about 16 grams, something like that. Approximate density, I'm not going to mess around with that. But this is something, yeah, this right now, like if I change this, it'll change the density because I basically overrode that mass. I can change the mass in here as well, but it's a little bit confusing because you can change it in here and change the override as well, but that's mostly the center of gravity, I guess, in this one. The length, I want to say it was like, let's just say it's like, make it look good, 2 inches. And let's say 2 inches. And we'll say it's about ½ an inch in diameter, something like that. So that kind of looks like an APRA, I guess. It's still just going to be a cylinder. There's no way to actually make it, you know, do that complex of a drawing inside of OpenRocket. We're going to stick it up here in the nose cone. Right there, so we could have a little vent hole right here, or we could even stick it farther down if we want. But that's a way to add a altimeter. You can also change the symbol if you want to do flight computer, changes the symbol. If you just want to have a deployment charge, that's deployment charge. Tracker makes that a little symbol. You can also do payload, which changes the symbol again. And recovery hardware, you can change it to that, as well as a battery. So it's up to you guys. I typically just set altimeter. Okay, so that's your rocket with an altimeter. You can see all the different airspeeds you're going to have, the length of the rocket, the mass of the rocket with motors, as well as the stability. Okay, I think that's all I'm going to show you for this episode, but make sure you stay tuned for the next episode. We're going to take this single stage, just a regular ejection charge motor, and change it into a dual deployment rocket, basically, which is something you'll typically deal with if you're going to go really high. So thanks for paying attention to this one, and stay tuned for the next episode.